Let us begin with a deliberate act of intellectual discipline. Set aside the diagrams, the arrows, labels, narratives that begin with a point in Africa and end with a globe filled in. And instead, imagine that none of those frameworks exist, that no one has ever told you how human dispersal is supposed to look, and that you are confronted only with fragments of evidence scattered across time and geography, fossils, tools, climate records, genetic signals, each incomplete on its own, but together forming a pattern that must be explained from first principles, because only then can we ask, without bias, what story the evidence itself demands, rather than what story we have been taught to see. In that stripped-down perspective, the first thing that becomes impossible to ignore is that by the last interglacial, around 130,000 years ago, populations recognizably within the range of Homo sapiens are not confined to a single region, nor are they clustered in one ecological niche waiting for an opportunity to disperse, but are instead distributed across a wide and continuous arc stretching from southern Africa through eastern Africa, across a dramatically different North Africa than we know today, into the Levant and into Arabia, South Asia, and even into parts of East Asia, forming not a point of origin, but a geographic network, because the Sahara and Arabia during this period were not the hyper-arid barriers that modern maps condition us to imagine, but green, dynamic landscapes of lakes, rivers, and grasslands, a permeable corridor that allows movement in multiple directions, meaning that populations could flow northward, eastward, and back again, blending, diverging, and reconnecting across a vast Afro-Eurasian interface that for a time functioned less like a set of continents and more like a single ecological continuum. It is important to be absolutely clear at this point that this is not conjecture, not a speculative reconstruction built on gaps in the record, but a synthesis grounded in converging lines of archaeological and genetic evidence, because stone tool assemblages, human teeth, and intentional burials attributed to early Homo sapiens or sapiens-like populations are documented across Mediterranean North Africa, the Levant, Arabia, and extending into South and East Asia during or around this interglacial window, while genetic studies identify what is often termed an early out-of-Africa signal, preserved today at low levels, on the order of a few percent, in populations such as Papuans and Aboriginal Australians, indicating that some lineages dispersed beyond Africa well before the later, larger expansions, and when these data are considered alongside patterns of cranial morphology, a continuity begins to emerge in which regional populations retain shared anatomical tendencies that later appear in Upper Paleolithic humans, so that fossils from Morocco are frequently discussed in relation to the emergence of early European forms often grouped under the label Cro-Magnon. Levantine and Central European material such as Meladec reflects a bridging morphology consistent with populations moving through or out of the Near Eastern corridor, and East Asian specimens are often compared with early modern humans like those from Owazi in Romania in ways that suggest broader population structure rather than isolated evolutionary events, while mitochondrial and Y chromosome haplogroups map onto these movements as signatures of expansion from structured ancestral populations rather than from a single homogeneous source, reinforcing the view that by the end of the Eemian, Homo sapiens was already a geographically widespread and internally diverse species. If one were to observe this Eemian world without preconceptions, one would not describe humanity as trapped, nor as preparing to leave, nor as confined to a narrow cradle, but as already dispersed, already structured, already interacting across regions that modern geography falsely divides into separate domains. And the implication of this is profound, because it suggests that before any supposed migration event occurs, the system is already complex, already multi-regional, already interconnected, and therefore any later simplification into a single-source narrative must be justified rather than assumed. And yet as the climate begins to deteriorate after the Eemian, as temperatures fall and precipitation patterns shift, that interconnected system begins to fragment, not uniformly, not instantly, but progressively, as the green Sahara dries and expands into desert once more, as Arabia loses its lakes and grasslands, as corridors close and distances between viable habitats increase, forcing populations that once moved freely into a set of shrinking ecological refuges defined not by political boundaries, but by access to water, vegetation and prey, so that instead of a continuous human landscape, we now have a broken mosaic of survivable zones, coastal margins, river-fed basins, upland pockets and forested regions, each capable of sustaining small populations but increasingly isolated from one another. It is into this already stressed system that the Toba super-eruption is introduced, not as the sole cause of change, but as a catastrophic amplifier of existing instability. Because while the eruption itself unfolds over a geologically brief period, days to weeks, the consequences extend far beyond the immediate blast zone, with ash dispersing across the Indian Ocean into South Asia, with sulfur aerosols entering the atmosphere and reducing solar radiation, with short-term cooling superimposed upon longer-term glacial trends, and with ecosystems that are already strained by aridity and cooling pushed closer to collapse, particularly in regions nearest the eruption where ashfall is thick and immediate devastation is undeniable, but also in more distant regions where the effects are subtler yet still consequential, affecting vegetation cycles, water availability, and the broader food web upon which human populations depend. In Southeast Asia and along the margins of the Sunda Shelf, where coastal populations may have been dense and heavily reliant on shoreline resources, the combination of ashfall, environmental disruption, and possibly localized tsunamis generated by volcanic processes would have created acute crises, selectively impacting populations in ways that are difficult to reconstruct in detail but easy to understand in principle, because coastal ecosystems are both rich and fragile, and sudden disruption can remove entire subsistence strategies in a matter of days, while inland populations, though buffered from the most extreme immediate effects, would still face longer-term challenges as climates cool and resources become less predictable, meaning that the impact of Toba is neither uniform nor globally annihilating, but rather regionally severe and globally additive, layering a sharp shock onto an already deteriorating system. At the same time, other human populations are experiencing parallel stresses, and the evidence for this is clearest in Neanderthals, whose genetic record shows a reduction in mitochondrial diversity, suggesting that many lineages disappear during this period, leaving behind a more limited set of surviving branches that later expand, a pattern that aligns with archaeological indications of contraction into refugeal regions such as Iberia, southern France and parts of the Balkans and Caucasus. And although Denisovans remain more enigmatic due to the fragmentary nature of their fossil record, their genetic legacy, preserved unevenly in later populations, especially in Southeast Asia and Oceania, points to a once broader distribution that was likewise fragmented and reduced, indicating that the environmental pressures of this period are not selective to one group, but systemic across the entire hominin landscape. Given this, it would be logically inconsistent to assume that Homo sapiens somehow escaped these pressures entirely, and indeed the genetic evidence from modern populations shows a clear bottleneck signal, particularly among non-African lineages, characterized by reduced diversity and a subsequent rapid expansion. But here the interpretation becomes critical, because while this pattern is often described as the signature of a small group leaving Africa and expanding outward, the pattern itself does not encode that narrative explicitly, and if one were encountering it without prior assumptions, one would simply observe that a population, somewhere, underwent a reduction in size followed by a period of growth and dispersal, and the location and structure of that population would remain open questions to be answered by integrating other lines of evidence. When we look to the geography of survivability during this crisis period, several regions emerge as plausible refugeia, not as singular sanctuaries, but as zones where conditions remained relatively stable compared to the surrounding landscape, including southern Africa, where ecological diversity and climatic buffering may have supported continuous populations, Mediterranean North Africa, where coastal influences moderated extremes, the Levantine corridor and adjacent regions, which historically function as a bridge between continents and retain pockets of habitability even under stress, the exposed basin of the Persian Gulf, which during periods of low sea level would have been a river-fed landscape capable of sustaining human groups, and parts of South Asia and Southeast Asia, where river systems and tropical environments provided resilience against broader climatic downturns, and crucially, These refugeia are not isolated in the sense of being completely disconnected, but rather represent nodes within a partially fragmented network where limited movement and interaction could still occur during favourable intervals. What defines this phase, therefore, is not a single point of survival, but a distributed contraction in which multiple populations persist in multiple regions, each reduced in size, each carrying only a subset of the genetic diversity that existed before, each subject to local conditions and local histories, and this is precisely the kind of structure that would produce both a global bottleneck signal and regional variation. Because while many lineages would be lost during the contraction, those that survive would do so in different places, setting the stage for a complex pattern of expansion when conditions improve. As the climate begins to recover, moving into marine isotope stage 3, roughly after 60,000 years ago, precipitation increases, vegetation spreads, animal populations rebound, and corridors that had been closed begin to reopen, allowing populations that had been confined to expand outward. And this expansion is visible across multiple lines of evidence, including the spread of Homo sapiens into regions far beyond earlier refugeia, the recolonization of parts of Europe by Neanderthals, and later by sapiens populations, and the rapid appearance of humans in Southeast Asia, and the crossing into Sahul, the combined landmass of Australia and New Guinea, which required deliberate sea crossings and therefore implies not only mobility, but planning and adaptation to coastal environments. Importantly, this expansion does not proceed as a single wave from a single source, but rather as a series of overlapping dispersals from multiple regions, each contributing to the emerging population structure of Eurasia, so that while some lineages become dominant in certain areas, creating the appearance of a simple expansion when viewed through the lens of surviving genetic markers, others persist at lower frequencies or become absorbed through admixture, and nowhere is this complexity more evident than in Asia, where genetic evidence reveals not only the spread of populations carrying mitochondrial haplogroups M and N, but also the persistence of Denisovan ancestry, particularly in Southeast Asia and Oceania, indicating that incoming populations did not simply replace those already present, but interacted with them, producing a layered ancestry that reflects both continuity and change. Australia, or Sahul, provides a particularly striking example of this process because the populations that reach it appear to branch early from other non-African groups and carry significant Denisovan ancestry, suggesting that they represent an early expansion from the eastern refugial system that then became relatively isolated due to rising sea levels, preserving genetic signals that are more difficult to detect elsewhere due to later population movements, and this isolation transforms Sahul into a kind of genetic archive, capturing a snapshot of the early expansion phase that can be compared with the more dynamic and reshaped populations of mainland Asia and Europe. When all of these pieces are assembled, the wide distribution of populations during the Eemian, the fragmentation of habitats during glacial cooling, the additional stress imposed by the Toba eruption, the contraction of multiple hominin groups into refugia, the genetic signals of bottlenecks followed by expansion, and the complex, regionally variable patterns of dispersal and admixture that follow, the resulting picture is not one of a single origin and a single migration, but of a system-wide contraction and recovery, in which multiple populations survive in multiple places and then expand outward as conditions improve, interacting, overlapping, and reshaping one another in the process. In that sense, the defining moment in this story is not the departure of a small group from a single homeland, but the survival of multiple groups across a fractured landscape, followed by their expansion into a world that is once again opening. And if we follow the evidence without forcing it into pre-existing narratives, the story that emerges is not less coherent than the traditional one, but more faithful to the complexity that the archaeological and genetic records reveal, because it replaces a single line with a network, a single event with a process, and a single origin with a system shaped by contraction, survival, and expansion. Thanks for watching.